Hi folks, in this lesson we'll be investigating systems of linear inequalities with word problems. And our goal is to use a system of linear inequalities to model a real-life situation. Now, we've been practicing graphing systems of inequalities, but with word problems, it's important to know that most of these problems will not give you a slope and a y-intercept. And so you'll be actually writing the equations in standard form. And standard form, if you're talking about an equation, it looks like ax plus by equals c. So you may want to write that down in your notes, that standard form is ax plus by equals c. Now, of course, we're not dealing with equations here, we're dealing with inequalities. So what you will see is ax plus by could be less than or greater than c. So with word problems also, the first thing you always want to do is figure out what x and y represent. That is always going to be your first step. So you'll identify the two things that the problem itself talks about, and then you're going to write an equality for each topic in the problem. Now, topics could include things like cost or profit or quantities like total, things like that. So basically anything you can total up, that would be considered a topic. So let's get right into the first word problem. Word problem number 1 says you can work a total of no more than 41 hours each week at your two jobs. House cleaning pays $5 per hour and your sales job pays $8 per hour. You need to earn at least $254 each week to pay your bills. Write a system of inequalities that shows the various numbers of hours you can work at each job. So as I said before, the first thing you want to do is identify what x and y are going to be. And you do have to write out words that say let x equal and let y equal. As you can see, I've done there. So let's identify what our x and y are going to be. Let's choose a yellow color here. So we're looking for two things that this problem mentions, and I can see that there's actually two jobs. So we have house cleaning and we have the sales job. So those are our two things that we're going to let be represented by x and y. So what we're going to do here, I'm going to make my little box. Okay, we're going to say let x equal the number. And let me just see if I can shrink that up a little bit more because it's a little bit too bold for my taste. And I'll just undo that real quick. So let x equal the number of hours. Because when we're talking about jobs, we work a certain number of hours. Number of hours house cleaning. Okay. And then y will be the number of hours for sales. Okay, and I don't know what we're selling here. Apparently it just says it's a sales job. So I'm just going to say number of hours sales in parentheses. And maybe we'll just stick the house cleaning in parentheses also. So those are our two things, x and y. And now we need to identify our topic. So if I look back at this problem here, I'm looking for totals. So when I see total of no more than 41 hours, that's going to be my first inequality here where I'm talking about the total number of hours. So I'm going to set this up. And we know that we have an x and a y being our number of hours. So I can say in this that x plus y would give me my total number of hours. And it says that we can work no more than 41 hours. That means that 41 hours is our max. So that means we can work up to but not including 41. So we are actually doing less than or equal to 41 hours. Okay, and then the other thing that we're talking about in this problem, our other topic, is it says you need to earn at least $254. So that's our profit. That's our other topic. So we need to set up a profit inequality. Now, profit is all about your hourly rate combined with the number of hours you work. So we can see house cleaning pays $5 per hour, so 5 times the number of hours you work, or 5x. And plus your sales job pays $8 per hour, so we'll do 8 times y, and that will have to be at least 254. Hopefully it's actually more than that. So we want to say in our inequality 5x plus 8y, okay, is going to be greater than or equal to $254. Okay, that way we can pay the bills and we're not going to get fussed at by any collections agencies, because that would not be a good thing. So those are our inequalities now. One other thing I should mention with word problems in particular is that this is a reality situation, where if we're talking about X and Y being the number of hours, we know that there are a couple of other inequalities we can actually include with this. And that would be that we can't actually work negative hours. We have to work up more than 0 or even just 0 hours. So we're always going to say X is going to be greater than or equal to 0, and also Y is going to be greater than or equal to 0. And in fact, these inequalities here, these guys, are going to be the ones that you typically will use first when you set up your system, okay? So with word problems, you might see more than just 2 inequalities. In fact, here I see 1, 2, 3, and 4 inequalities, and that's pretty typical with the word problem. So let's take a look now at example 2. And it's all about gasoline. So it's fuel A costs $2 per gallon and fuel B costs $3 per gallon. Your car can hold 12 gallons of fuel. You have at most $18 to spend on fuel. Write and graph a system of linear inequalities to represent this situation. So again, we're going to identify X and Y. I see 2 things. I see 2 types of fuel, fuel A and fuel B. So those are going to be X and Y for us now. So I'm going to go down here to let X equal and let Y equal. And you do have to write let X equal and let Y equal. Okay, so let X equal, we'll say number of gallons, because we're talking about gas, number of gallons of A, fuel A, and then we'll say let Y equal number of gallons of fuel B. Okay, so we have our X and Y identified. Now let's find our topic. So in our problem here, we see that we have a total of 12 gallons of fuel. So that's our first inequality. After, of course, we know we can't say we can get negative gallons of fuel. So we're going to go ahead and say X is going to be greater than or equal to 0, and Y is going to be greater than or equal to 0. And then our third thing is, since we know our car can hold 12 gallons of gas, the X and Y combined, or adding them, can be less than or equal to 12, but it certainly can't be more than 12, okay? And you can certainly have less than 12 gallons of gas. In fact, that's the reason why you need to get more gas, is your tank is not full. So that would be our first inequality. And then our other topic, it says you have at most $18 to spend on fuel. So this is our cost inequality. So that's our other topic, is a cost idea. So looking back at the prices, $2 per gallon for A and $3 per gallon for B. We can say 2x. Oops, let me undo that. That was an ugly 2. 2x plus 3y. And at most we have $18 to spend. Hopefully you spend less than that, so that way maybe you can get a bag of chips or something, or maybe a drink from the cooler. You want to say 2x plus 3y is less than or equal to 18. So now we have set up our inequalities. This is our system here. This all 4 inequalities here. And then our goal is to graph this thing. So we're going to have to identify these things in y equals mx plus b form. Now, I trust that you guys can do the math real quick. I'm just going to do some quick conversion. If you have questions about how that was done, you can certainly ask your teacher for help. But we're going to end up getting y is less than or equal to negative x plus 12. And then for the second one, this will become y will be less than or equal to negative 2 over 3 x plus 6, and you get that because you divide everything by 3 at the end. So now these are the things that we will be graphing here. I'm just going to highlight these in green, I think. we'll do light green. We're going to be graphing x is greater than or equal to 0, y is greater than or equal to 0, and also y is less than negative x plus 12, and y is less than negative 2/3 plus 6. So on the next slide, I've gone ahead and copied down those inequalities again for us, just to make things a little bit easier. And I even put on a graph for us. So we're going to go ahead and try to graph this. So when I see x is greater than or equal to 0, remember x is all of these numbers. Okay, this is our x-axis here. So I know I'm going to be graphing anything that is more than 0. In fact, it's just everything that's on the right side. So graphing the line x were equal to 0, and I'm just going to make this a little bit thicker here so we can see it a little bit easier on our graph. I'm going to be graphing basically the y-axis here. And I think that's about the straightest line I've ever managed on this thing, so go me. And then we have y is greater than or equal to 0, which is actually going to be the x-axis, okay? Now, for the greaterness of all that, we could be shading everything that is in the first quadrant here. So let's pick a color here. In fact, I will just stick with the green because it's just so much fun. So we would be shading everything in here. It's so pretty. Okay. And then, of course, we have our other inequalities that we need to graph. We need to graph these lines. So y is less than or equal to negative x plus 12. Remember, with graphing, you want to start at your y-intercept. And let's see, I'm going to have to make this a little bit thinner. We'll choose that guy. And at 12, we're at right here. Let me see if I can actually, let's make it thicker, I think. We'll make it a nice point. 12, right there. And then the negative x means I go down 1 over 1. So I go down 1 over 1, down 1 over 1, down 1 over 1, etc. And eventually I would have a nice set of dots to follow. I'm doing them all just because graphing on the iPad is not a very fun thing to do. It is never very pretty. So bear with me here. Hopefully this comes out okay. So I'm going to graph this line. And I'm going to try to use a piece of paper to help me keep my line straight. So if weird things happen, please forgive me. Graphing that thing. Sounds like to make everything better. And I did end up doing something that looked like half of a face. That was kind of weird. So I'm just going to do this, and that would be our line here. And it's solid because we are including. And then I get rid of that point there. Go away, go away. Thank you. All right, and then as far as the shading goes, since y is less than, I would want to go below the line. I'm going to do this one in pink, and I'm just going to shade down here. Whee! There it goes. And then I have my other line to graph, so we're going to start at 6. You can kind of see that point. There we go. And then I would go down 2 over 1, 2, 3, puts me right there. Down 2 over 1, 2, 3, puts me over here. And so I can graph that line as well. Let's see here. Oh, go away. Go away. I don't want you. Thank you. In fact, I don't want that either. Go away. All right, and let's see, I'm going to try to graph this line without the paper because I don't think it helped all that much, but I would graph that line. Okay. And in this case, we actually don't have a very interesting region that ends up being shading because typically we would get something a little more odd shaped. Really, this turns into a triangle, which isn't all that fun. Not that I have anything against triangles, but it is what it is. So what I'm going to do here now is pick a new color, blue, I think, and I'm going to make that the extra crispy area because, as we can see, that's the area that will be contained by all of them. So honestly, it doesn't even matter about the other line because this last line, this guy, was the real constraining inequality with this particular problem. Now let's, I think I'm going to pause here because I'm about running out of time and I don't want to start a new problem in the middle and not finish it by the end of the video. So be prepared. There will be a part 2 and possibly even a part 3 with this unit or this lesson, because this is a big beastly lesson.